See my slide. Okay. Hi, Assalamualaikum. Good afternoon to everyone. My name is Ahmad Ashraf, chemical engineer from chemical section. Today I will present about the hydrogen fuel cell. Today we will look onto the introduction of the fuel cell. What is it fuel cell about? What is the usage or the application of the fuel cell itself? And then the second one is the working principle, how fuel cell works, how it converts from chemical into the electricity. And then we will look onto the fuel cell type. We will look into the criteria of the fuel cell, which type of the segment of the fuel cell will be the most demanding in the market. And then we will look onto the design consideration and issues occurs in our fuel cell. For the introduction, what is a fuel cell? It's a device that converts chemical potential energy into the electrical energy. Basically, in fuel cell, we need fuel, and also usually we use hydrogen and oxidizing agent such as oxygen to convert into the electricity. It uses electrochemical technology to produce electricity. The generation of the electricity is totally depends on fuel supply. What is the advantage of the fuel cell? The first one is clean energy. It produces less emission. It can fulfill our nation aspiration on decarbonization to reduce the carbon emission on the road. It's the future of our energy sector, which we should take some advantage from this technology. And then it has high efficiency and quiet. Most of the fuel cell efficiency is doubled up to the efficiency of our conventional internal combustion engine, and it has no moving part in fuel cell. And then it has low maintenance costs. The maintenance cost of internal combustion engine is much higher compared to the fuel cell because of the usage of different technology. Fuel cell use electrochemical technology which has less wear and tear component of the fuel cell. For the fuel cell application, can be applied in stationary application such as in power generators, housing areas, and to power up the factory plant. And then for the portable application, it can be used for our electronic gadgets and also our device. And for the transportation application, can be cars, public transport, and also heavy-duty vehicles to reduce carbon emission on the road. For the military, it can be used in submarine for energy generation. That's an example of the application of the fuel cell. How fuel cell work? The first step is the hydrogen fuel will flow to the anode, while the oxygen from the air will flow to the cathode. At the anode, it contains catalyst that generates the ions and the electrons. From the chemical equation, the hydrogen is split into the ions and the electrons. For the electrolyte will permit or allow the movement of the ions from the anode to the cathode. And for the cathode, it contains catalysts that cause the ions, the electrons, and the oxygen to react to produce water, which is our byproduct from the fuel cell. When both electrodes are connected to the external circuit, it will generate a direct current due to the moving of electron at the circuit. You might require inverter to convert from DC current to the AC current, since most of the electrical appliance uses AC current to operate. Then for the components, the electrolyte, we need electrolyte, which is to permit the migration of the ions from the anode to the cathode. It can be potassium hydroxide, carbonates, phosphoric acid, and also the polymerase exchange membrane (PEM). For the fuel, our fuel cell will operate when there is a continuous flow of the fuel. Usually we use the hydrogen fuel. And for the anode catalyst, usually we use fine platinum powder, which is used to enhance the generation of the ions. And also for the cathode catalyst, we use to enhance the oxygen reduction reaction at the cathode. We often use nickel. And last one is the gas diffusion layer. We must include in our membrane assembly. The gas diffusion layer is used to enhance the mass transfer of the gas to the catalyst. However, this type of the material depends on the type of fuel cell that we choose. Sorry. Okay. This is the electrical calculation from the thermodynamics of the electrochemical cell. We can evaluate how much electrical work is produced by the fuel cell. And then the theoretical cell potential or voltage can also be calculated using Nernst equation at the bottom. This is just a theoretical. However, there will be a voltage drop at some point which we can identify from the polarization curve. Okay. Then to know about how much the amount of gas required by the fuel cell, the feed gas amount required can be estimated by applying the Faraday's law shown in the slide. Then let's take a look on the features between the main type of the fuel cell. The first one is proton exchange membrane fuel cell, the alkaline fuel cell, direct methanol fuel cell, phosphoric acid fuel cell, molten carbonate fuel cell, and also the solid oxide fuel cell. There are low temperature fuel cell and also the high temperature fuel cell. The low temperature fuel cell are easy to handle because it has fast startup time, while the high temperature fuel cell will have a longer startup time because we need to heat it up first until it reaches the operating temperature. However, it depends on the application that we use and the suitability. For the application, we can look at the PEM or proton exchange membrane fuel cell has very reliable because it's suitable to be applied for stationary, portable, and transportation application when compared to another fuel cell. Let's take a look on the operating temperature. Usually, the high temperature fuel cell will have higher energy efficiency to convert into the electricity. But however, the operating temperature also affects the material of the fuel cell. Design of the material should be compatible with the operating temperature that we set. Okay, next. The fuel, mostly of our fuel cell use hydrogen fuel. But there is some fuel cell that use methanol and also natural gas and also the hydrocarbon as fuel. Okay. For the electrical efficiency, you can see that the lowest one is the PEM fuel cell compared to another fuel cell, it's quite higher than PEM. But it's still reasonable since this is approximately double up the efficiency of the internal combustion engine, which is about 20% only. So it will increase our efficiency if we use the PEM fuel cell. It's still relevant. Okay. And for the electrolyte, it can be polymeric membrane, alkalis, methanol solution, phosphoric acid, molten carbonate, and ceramic oxide. But the different electrolyte will indicate a different type of fuel cell. We can use either that we will choose. And for catalyst, it's also we have many types of the catalyst. But our selection of the material for the catalyst also affect the price of the fuel cell itself. For example, platinum cost is very high, so that the catalyst material can be modified so that it will lower down the cost by using another combination, the catalyst. And then for the selection of fuel cell type to be developed, I did some market research. From my finding, proton exchange membrane or PEM fuel cell is expected to be the biggest contributor in the fuel cell market. Oh, okay. Can you hear me? Okay. 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 For the to select the fuel cell type, I did some of the market research. From my finding, I found that the PM fuel cell technology is expected to be the biggest contributor in the fuel cell market. This is due to growing demand for the clean energy, high efficiency, low operational cost, quick maintenance because it's easy to be maintained, and this is reliable and easy to operate. The last one is most of the public transport will rely on the fuel cell base in order to reduce the emission, especially PM. It's suitable for the public transport also. And then next, for the segment in terms of the application, okay, according to the markets and markets 2020, the transportation segment will be the top one. It is due to the widespread usage of the fuel cell technology among the heavy-duty transport in regions like Asia Pacific, which boosts the demand for this fuel cell. And then for the end user segment, according to markets and markets 2020, fuel cell vehicle would be the top one among of the another segment. It is due to the growing demand for the decarbonization. From what I presented that, I suggest that we should develop and put investment on the PEM fuel cell to be used in transportation segment. Also, it can be a fuel cell vehicle. And then we will look onto the design consideration and issues in PEM fuel cell. The first one is the cost, especially for the platinum catalyst. This can be overcome by modifying the electrode material by reducing the amount of platinum catalyst without reducing its performance. For instance, the LED power system has used the catalyst enhanced with carbon silk to reduce the cost. And then the Untitled University also has proposed the combination of the platinum alloy over graphene nanoparticles as alternative. Next, PM fuel cell should have a good water and air management, especially for the membranes. Must be hydrated. The rate of water evaporate and water produced by the fuel cell should be controlled. If the membrane too dry, it will increase its resistance. It has potential to crack. If the water is slowly evaporated, the electrode will be flooded with water. And then the PEM fuel cell also should get a proper temperature management to avoid the thermal loading. Since the reaction occur in our fuel cell is highly exothermic, so you need to maintain the temperature. The last one is specified durability design should be applied regarding on the application that we choose to develop. For instance, fuel cell durability for mobile vehicles should be designed at very extreme condition. We have the vibration and also but we have to consider the environment. And then this is the example of the schematic diagram of vehicle fuel cell system. It's quite complicated because we need a proper process control to maintain all the parameters involved, such as the temperature, pressure, flow, and also the humidity of the cell. So, thank you. That's all from me.
Thank you, Mr. Ashraf.